Okay, so for this question here, okay, we're dealing with the physics that accelerates a bullet through the barrel of a gun. Okay, so when a gun is fired, right, the trigger is pulled, the hammer comes forward, and it hits the primer on the bullet. The primer on the bullet is basically something that will just make a spark inside the round where the powder is stored. Okay, that spark ignites the powder, and then there's an explosion. Okay, now that explosion is contained within the chamber and barrel of the weapon. Okay, so the gases rapidly expand as they do in any explosion, but they're contained and they can't escape. So they propel the round or the head of the bullet forward, okay, and out of the barrel. Okay, so that's what's going on here. Is those expanding gases are propelling the bullet out the end of the rifle barrel. Okay, inside the barrel of the rifle, there's riflings, okay, which is basically just grooves that are cut into it that enable the bullet to spin, which increases the distance that it will fly and its accuracy. Okay, if the bullet doesn't spin, then it can start to tumble, and that makes it obviously not go as far and not be as accurate. Okay, so all of that stuff goes on to produce the acceleration that we're going to calculate here. Okay, so what we know is we know the length of the gun barrel, which would be the distance traveled by the bullet during the acceleration. Once the bullet leaves the rifle, what is it doing? Yeah, it starts to accelerate negatively. Okay, it starts to slow down. Right, as soon as it leaves the barrel and those expanding gases are no longer pushing on it, air resistance starts to slow it down horizontally, and gravity actually starts to accelerate it vertically. Okay, and it falls, which we'll talk about when we talk about projectile motion soon. Okay, so our distance is 0.75 meters. Okay, and we know that the acceleration is incredible. It is 5.35 times 10 to the 5 meters per second squared. Okay, that's a lot. Okay, that is a huge acceleration. But when you think about how fast a bullet goes, okay, and it has to accelerate to that velocity over this length, and it has to accelerate very, very quickly. All right, so what speed does the bullet exit the barrel? Well, what can we assume its initial speed to be? Yep. Okay, so I've got VI, I've got A, I've got D, and I'm looking for VF. All right, so we only have one formula we haven't gone over yet from our list of 5 formulas, and that's this one. VF squared equals VI squared plus 2AD. And if you recall, I said that one's going to be used all the time for projectiles. And here we go, here's a projectile question. Okay. So I'm looking for VF. This formula solves for VF squared, so what do I have to do? Yeah, I have to square root everything. So I'm going to have VF equals the square root of VI squared plus 2AD. Okay, that squared doesn't go away just because it's underneath the square root. I'm square rooting the answer to all this. Okay, so all I have to do then is plug in my numbers. So that'll be 0 squared, which is 0, okay, plus 2 times our acceleration, which was 5.35 times 10 to the 5 meters per second squared, times 0.75 meters. Perfect time. Okay, so I'm not going to bother to put the 0 squared in there. I'm just going to go 2 times, and then I'm going to put in brackets 5.35 E5. Okay, there's my acceleration times 0.75. Okay, so I have 3 significant digits here. Okay, and so that's going to give me 896 meters per second. Is that fast? It's really fast. To give you a comparison, the speed of sound is 330 meters per second. So this bullet is traveling 2.5, almost 3 times the speed of sound. Here's a scary thought. You'll never hear the bullet. No. the bullet that hits you, you'll never hear it because it travels faster than the sound that fired it.
If it hits you in the arm, you'll hear it in a second.
After,
Yeah.
I'm saying before, okay? You won't hear the shot, you're just gonna fall. Because the bullet will get there before the sound. In some cases, well before it, okay? Depending on the length of the shot. Okay? The bullet can really outrun the sound that caused it to be fired. Right? This is true for lots of, I don't know if you guys have seen like the American Sniper movie and all of that kind of stuff or read the books. Like, it's, some of those shots are pretty amazing. The record for the longest shot is held by a Canadian sniper in Afghanistan, and it's nearly 4 kilometers. Okay? That person for sure never heard the shot. Okay? Because the sound would have dissipated over 4 kilometers. Okay? Unfortunately, the bullet that it propelled did not.
Did you say 4 or 40?
4.
Okay.
Yeah, no, nobody's shooting 40 kilometers. That's for artillery. Artillery will go 40 kilometers, but no, a single rifle shot, no. But think about this, guys. For a bullet to travel 4 kilometers, okay, that's a long way, right? And you've got all kinds of things like wind that could push it right or left over that 4 kilometers. Okay? In traveling 4 kilometers, I mean, let's just do the math here. At 896, so 4,000 meters, it was just under 4,000, but we'll say 4,000. The bullet is in flight for 4.5 seconds. Okay? So wind can push it right or left. Okay? Air updrafts could push it up. Gravity pulls it down, that's guaranteed. Okay? Throughout the entire shot. So the person who hits that shot is not aiming at their target. Okay? They have to correct for all of that, especially drop.
That's why you always aim higher than the target.
It's exactly. If you've ever, even with a bow and arrow, if you've ever done archery, you always have to aim above your target because gravity is going to pull the arrow down as it flies. Okay? Just to give you an idea here, if we do another acceleration kind of question, okay, given how much that bullet would drop over that length of time, so we just calculated it was about 4.5 seconds, okay, we can do this. We can calculate how much higher than the target the sniper would have to aim in order to make that shot. This will this formula here, if I plug 9.81 in for gravity, in for acceleration, and 0 in for this, okay, so we'll go 0.5 times 9.81 times this number here squared. He has to aim 100 meters above the target. Okay? Now, they don't literally go, okay, there's my target, like this. Okay? They actually adjust the scope. So they crank the scope and the scope will go down like this. Okay? It'll aim down, so they have to lift the rifle barrel to get the target in the sights of the scope. That's what corrects for the drop. Okay? If you've ever seen any of those sniper movies, the spotter is calling out those numbers in the movies. They're saying windage is this many, clicks or this many notches or whatever, whatever measurement they're using for that they have between themselves. Okay? They're telling you have to aim this much higher. You have to correct for wind this direction. Okay? And they do it. Okay? It's kind of scary that there are people out there who can do this. Because that's, you can just rock yourself to sleep. No, that's not somebody you want to make angry. Yes. Okay, so is that formula making sense? Let's look at the manipulations of that formula. So we got VF squared equals VI squared plus 2AD. So we've already looked at how to solve for VF. Okay. What if I want to solve for VI? Okay, Tegan?
Don't you just subtract 2AD to the other side?
Mm-hmm. VF squared minus 2AD will give me VI squared. So I have to
Square root.
There I got VI. Okay, that's not too tough, right? We know we can move things over in chunks. Okay, what if I want to solve for A? should I move first?
The
The VI, yeah. So. Okay, it's going to equal 2AD, so I want to leave A over there. What do I have to do in the D? 2D. If I wanted to solve for D, I divide by 2A. Everybody all right with that? Our algebra is, we're shaking the rust off of the algebra here. Getting into that. All right, I would like you guys to try these ones here. It's big enough to read. Getting too big tonight, can't see the answers. Okay, give you a couple minutes on those. All right, so on our first one here, okay, we've got a jetliner that lands on a runway at 70 meters per second, so that's where the question starts, so we have to assume that was our initial velocity. Reverses its engines to provide braking and comes to a halt. Okay, 29 seconds later. Do I need the formula we just went over for this one? No, because it's a trick. I just wanted to see how many people are paying attention. Okay. I don't have the givens for Vf squared equals Vi squared plus 2AD. I do, however, have the givens for this. And the reason I did that is because this is always the challenge with acceleration problems. Figuring out which formula do I use based on what I have. Okay? So for this one, this is what I would use here. So I would have 0 minus 70 over 29, okay, which would give us our negative 2.4 meters per second squared. Okay? And that's all we can give. Okay? I hate when they do something like negative forward. Just say backward. Okay? Yeah, it sounds silly. I never say negative east when I mean west. Okay? And I never say, you're negative right, because that's just wrong. That's terrible. Okay, what's the length of the runway the jet requires to come safely to a complete stop? All right, I now have VI, VFT, and I have A. Can I use any formula from our list at this point? Yeah. Yeah, you can pick whichever one you want. Okay, you have all of the data now. You could use any of the formulas. Okay. If it were me, I would probably try to do this as much as possible with the, something simple that I wouldn't have to manipulate. Right? This already solves for D, and I don't have to do any algebra with it, so why not just plug in my numbers here? 70 times 29 plus 1/2 times negative 2.4, okay, times 29 squared should give me 1 kilometer. Or 1.0 times 10 to the 3 meters would also work, okay, for that one. Okay, everybody all right there? Okay, remember that on number 2, you're given something in kilometers per hour and something else in meters per second squared, so you got to convert those kilometers per hour. Okay, give you a couple more minutes to get ahead of me on number 2 here. Okay, so on our second one, okay, we have on-ramps, okay, and contrary to what it seems many drivers are unable to understand, these are used to get you up to highway speed before entering the highway. Not like 6 out of 10 people on that one over there who merge over into traffic at 80. Drive me insane. Which doesn't do much probably. But anyway, okay, so we have this on-ramp that is trying to get people from 50 to 100 kilometers per hour. So they're giving us, okay, our initial and final velocity. So 50 divided by 3.6, okay, is going to give us 13.88. So we know now that the initial velocity is 13.88 meters per second. Okay, the final velocity will obviously be twice that, so 27 point something. Okay. All right, 27.77 meters per second, and they have the average acceleration of a vehicle using that ramp, which is of course what they have to do when they design one. Okay, they can't make it for the slowest vehicle, right? That semi-truck is just gonna need more than they can possibly provide, okay? So they've gotta do it for the average vehicle, right? 3.8 meters per second squared. And that would be a positive number because obviously they're increasing speed here. Okay, so we're looking for the minimum length or distance, okay, of the on-ramp. So we have VF squared equals VI squared plus 2AD. We can use and should use that formula for this question, manipulating for D. So we're going to subtract VI squared for both sides, okay, and then divide by 2A to give us D. What do you suppose people forget to do when they use this problem or use this formula?
Put the top and bottom in brackets.
Put the top and bottom in brackets, and they forget to square. Okay? They write the square, but they forget to square. Okay? Makes a big difference on your answer. All right, so what we're looking at here is 27.7 squared minus 13.8 squared, okay, divided by 2 times 3.8. Okay, those were the numbers that we were given in the question. Okay, so we are going to have our 27.7 squared, okay, minus our 13.8 squared. I didn't bracket it because I'm doing that operation first, okay, and then I'm going to divide by the bottom, which I am going to bracket 2 times 3.8. All right, so they are going to have to make that on-ramp 76 meters long. Everybody all right with that? All right, questions there on any of those acceleration formulas? Okay, so we're going to spend today working on just some problem solving, getting the hang of when to choose which formula, maybe working on our algebra a little bit. Tomorrow, we're going to do lab. Okay, we're going to have the carts going down the ramps, okay, and recording their velocity and distance and all of that kind of stuff, and doing some velocity versus time graphing, and then on Wednesday we will start projectile motion. Okay, I'm going to give you a couple here that have different types of wording, just so you get kind of an idea and some experience in questions that are worded maybe strangely or differently, okay, but still give you enough information to solve them. Right? So this one's kind of a prime example. This one doesn't seem like it gives you very much information, does it? Okay, and it doesn't. It gives you one number. It gives you 6.0 meters above the ground. So we know that's the distance that the bolt is going to fall. But the question from the context of the question gives you 2 other pieces of information. What are they?
Acceleration and initial velocity.
Gives you the acceleration and the initial velocity. Because we have to assume this is on Earth, unless we're told otherwise, we know that gravity would be 9.81 meters per second squared. Down, okay, or negative. And because it fell, it wasn't thrown or projected in any way, its initial velocity is 0. It's like being dropped. Okay, so VI equals 0. So that's sometimes what we have to do. We have to, from the context of the question, get some of the other givens.
Wouldn't the final velocity be 0 as well?
We don't consider after it hits the ground because the bolt would bounce. Right, like it would hit the ground, it would bounce, and there would be all these other progressions to it. So we're stopping our question the instant it hits the ground. So before any other, because that's a separate acceleration, right? Yeah. Okay, and that's a good question. So we've got this, and we're looking for how long it would fall for. Right? That means we're using the formula I told you wouldn't have to use to calculate time. But since VI is 0, I can use it. Okay, so I'm going to manipulate by dividing both sides by half of A and square rooting to get T. Okay, so T will be the square root of 6 over 1/2 times 9.81. Now, I have 9.81 negative here in my givens, but I don't have it negative there. Why?
Because time is a scalar quantity, it doesn't really go back.
Nope. That's true. Time is a scalar quantity. It doesn't go back, but that's not why I didn't make the 9.81 negative there.
Because you can't make a negative from the outside.
Nope.
Because you can't square it with negative.
It is because it can't square root a negative, and why else?
Was negative would be going up.
Nope.
Distance is also negative?
Right. It's falling. Isn't that in the same direction it's accelerating? Yeah. So I can make them both positive because it's all in the same direction, or I can make them both negative. It makes no difference. If I make them both negative in the givens, then I got to make them both negative in here. Okay? I make them both positive in there because it doesn't matter. It doesn't change direction. The acceleration and the displacement are both down, so it makes no difference in this case. If it changes direction, starts out going up, then I have to make acceleration negative and look at it that way. Okay? All right. Any other questions on that one? Try that one. So we're looking for the final velocity of a rock propelled over a 0.30 meter distance by an acceleration of 22 meters per second for 0.72 seconds. Okay, let's have a look at this one. So we're looking for VF. Okay, a rock is propelled over a 0.30 meter distance, so they told us D, okay, by an acceleration of 22 meters per second squared, okay, for 0.72 seconds. Okay, so what formula should I use?
D equals df times t minus 1/2 at squared.
Exactly, that's the one I have the information for. Okay, what happens here sometimes is people assume VI is what? Does it ever tell us that?
No.
And this isn't a situation where I can get that from the context. It doesn't say it was dropped or anything like that. It just says it was accelerated. It may have already been moving. Okay, we don't know that from the context of this question. Okay, so I'm looking for VF. So the first thing I want to do is add 1/2 AT squared to both sides. Whoops, not equals D plus. 1/2 AT squared equals VF times T. Divide both sides by T. Okay, there's my formula. I just need to plug in my numbers now. So that will mean 0.30 plus 1/2 times 22 times 0.72 squared divided by 0.72. All right, so we're looking at a final speed here of 8.3 meters per second. Okay, can't really put a vector on that. They never gave me any vectors in the question, right? I have to assume that this is all speed, okay, and distance. So it'll end up being scalar. Questions on that one? Okay, see if you can figure that one out. All right, let's have a look at this one. So we are looking for the initial velocity. Okay, we know that it slows with an acceleration of 150 meters per second squared. So I'm going to make that negative because they told me it slows. Okay, for 2.252 seconds. Okay, and its final velocity is 65.2 meters per second. Okay, so ballistics gel, I don't know if you've seen like any like stuff on TV. They used to use this on Mythbusters. They use it on like crime shows all the time. Okay, it's basically like Jello, except it's more like the consistency of the human body, and they put in like fake bones inside so that they can mimic the situation that a projectile would have encountered when it encountered the victim in question. So if they're seeing from their crime scene investigation that the bullet is still in the person, then they know that the bullet was probably fired from a long ways away or from a low velocity like weapon of some kind or something like that. It can help them to determine and kind of figure out where people were at the time of a crime. So it's very helpful in that way.
Forest and Fire also uses ballistic dummies.
Who does?
Forest and Fire, they use ballistic.
Oh yeah, to test the how well the
sharpness
stuff
of the
cuts.
bullet,
Yeah. Yeah, they used to use it in a show called Deadliest Warrior too. I don't know if anyone ever saw that. It used to be on Spike. It was a great show. They would pit like two adversaries together who would have never met each other in history, to see who would win, and they would have them like, test it out on the ballistics gel and stuff like that. It was pretty cool. Like they had like Al Capone's gangsters up against like Roman centurions, like who would win. It was pretty cool. All right. So we're looking for VI. We have A, T, and VF. All right. So I would say this is probably our best bet. Okay, that's the information we have. That's the formula I would use. All right, so I'm going to multiply both sides by T, add VI to both sides, and then subtract T times A. So I will have VI equals VF minus T times A. So that'll be 65.2 minus 0.252 times negative 150. And it's pretty important that I leave the 150 in there. Otherwise, the question will tell me, or the answer will tell me that my bullet sped up as a result of hitting the ballistics gel, which obviously is not possible. All right, so 65.2 minus 0.252 times negative 150 tells me that this was a pretty slow bullet when it hit the person, 103 meters per second. Okay, like that you could go and step out of the way, and he'd look like all matrixy. Dodge bullets if they all moved at 100 meters per second. Okay. All right. So we only had what in there? 3 significant digits. So it would actually be 103 meters per second. Okay. All right. Is this sort of making sense? The process we go through. Okay. So write down your givens. Choose your formula. Okay. Manipulate. Plug in your numbers and solve for your final answer. All right, try that one. How far a plane flies while accelerating from 123 to 300 meters per second. So in this one, we're looking for how far, so we're looking for distance, okay? A plane flies while accelerating at positive 4.252 meters per second squared, and it's doing so from an initial velocity of 123 meters per second to 300 meters per second. All right, so I would say we're looking at this formula. VF squared equals VI squared plus 2AD. And most commonly, we use this formula to get D. Okay, especially when we get to projectile motion, we're always using it to get D in a projectile motion problem. So this will be a very common manipulation that you will do often. All right, so we'll have VF squared minus VI squared divided by 2A as our manipulation to get D. So that'll be 300 squared minus 123 squared divided by 2 times 4.52. Okay, so remember, you do need to bracket your top and bottom operations here so that it does them separately. All right, so we're looking at what do we have? 3 sig digs there, so 8.28 times 10 to the 3 meters. Would be our distance traveled. Okay, do I need a vector on that? I don't. They asked me how far it would go, right? How far is distance, so we don't need a vector on that one. If they'd asked me for the displacement, then I would have to say positive, because that's all they gave me in the question was positive, right? Okay, try this one. Looking for initial velocity on this one. So on this one here, we are looking for the initial velocity. Okay, the runner finishes the race at 15 meters per second. Okay, and the race was 150 meters. Okay, and they took 21.2 seconds. All right, so that's our information. We're looking for VI. What formula should I use here?
D equals VI plus VF over 2 times T.
Exactly, this one. We don't have the acceleration on this one. Okay, so we'll have to use that one. Now I know it doesn't say they accelerated uniformly. It should. I did tell you that any question using this formula should have those words in it. Okay, and it should. Okay, in this case, it is the only formula we have the information to use. All right, so D equals then, so we're trying to, manipulate for VI. So we're going to divide both sides by T, and then we're going to multiply both sides by 2, and then we're going to subtract VF. So we will have 2D over T minus VF equals VI. Okay, so that'll be 2 times 150 divided by 15. Divided by 21.2. And then we will subtract from that our 15. Okay, so 300 divided by 21.2 minus 15. Okay, so they were moving slightly backwards. Okay, which if you were in a set of starting blocks wouldn't be unheard of, because when you're holding yourself in your starting blocks and you're just about to push forward, sometimes you rock back a little bit to load up one leg. You shouldn't, but some people do. Okay, and that could account for that slightly negative initial velocity. Right. Okay, how are we feeling about this stuff here? Okay. I mean, it's just algebra, right? Like, as long as we can pick the right formula and manipulate it, you can't really go wrong on it.
That one's hard to manipulate though.
Yeah, it's a bit tricky for sure. We have to remember that if we want to get at anything inside the brackets, we first have to move T over. And then after that, it's just multiply and subtract, right?
By 2. Yeah.
Multiply, right? So first I divided by T, then I multiplied by 2, and then I subtracted VF over to the other side. As long as I get rid of those brackets, right, I can start moving things. Okay, so in your booklet, in your workbook for this unit, okay, you will find these questions. So if we go there. I can't remember what page it's on, so I'm just trying to find it for you here. Okay, so we are looking at page 6 here. So start on question number 2. Don't worry about question number 1. It's so poorly worded that I'm just going to skip it. Okay. Let's try starting with question number 2. It's a lot like the first one we did here. It seems like it doesn't give you very much information, but it really does. Okay. And the answers are there in bold, so you can check them as you go. Number 2.
The workbook?
Oh, it's on page 6.
Okay.